So our steps for all reciprocal graphs. We are first going to graph the function on the bottom, or in the denominator. In this case, we're first going to graph 4x minus 3. And it's going to be helpful if you have 3 colors for this. Maybe you use pencil for one graph, your original graph, blue for your final graph, and you're going to need to use a red pen for your asymptotes. Yeah, intense, eh? So we're going to graph the function in the denominator. That's going to be y equals 4x minus 3. We're going to draw our asymptotes. We're going to make our vertical asymptotes at every x-intercept on our original graph. If it's an x-intercept, that means that on the bottom, then you would be dividing by 0, and that would be a non-permissible value. And we're going to draw a horizontal asymptote at y equals 0. This will always happen for our lines and parabolas. Next year in grade 12, you'll see sometimes where there's not a horizontal asymptote at y equals 0 for reciprocal graphs. But for this year, all of our horizontal asymptotes for lines and parabolas will be at y equals 0. The reason for that is if you imagine a line, can you see that the y values will keep getting bigger and bigger and bigger as it goes up forever? So anytime your graph's y values get bigger and bigger and bigger, as soon as you do 1 over that, they're going to get really, really close to 0. Same thing with a parabola. Whether the parabola is going up or the parabola is going down, your y values are going to get very big, either very big positive numbers or very big negative numbers. And if you do 1 over that, you're going to get very close to 0. So for now, it's straightforward, it's easy. We'll always have a horizontal asymptote at y equals 0 when we're doing the reciprocal of a line or a parabola. Then we'll plot some points on our original and reciprocal graphs. And finally, 4, which is connected to 3, we're going to finish our graph by showing the asymptotic behavior.
What?
So we're going to show the asymptotic behavior.
What?
You'll see what it looks like.
That's bad, right?
All right, so here we go. We're going to graph 1 over 4x minus 3. We've got our steps here. Step number 1 says, can you graph 4x minus 3? So this is maybe where you take out your pencil, choose a color. Minus 3 would be your y-intercept. A slope of 4 means go up 4, 1, 2, 3, 4 over 1. There's another point, go up 4, 2, 3, 4 over 1. There's a second point, and we have our original line. Now we need to draw our vertical asymptote at all x-intercepts. Do you remember algebraically, how do we find an x-intercept?
You don't use your calculator.
No, make y equal to 0. So if I made y equal to 0 and y equals 4x minus 3, I would just have to move the 3 over to get it 3 equals 4x, divide by 4, and I get 3/4 or 0.75 as my x-intercept. Does that look about right where it crosses the x-axis? More or less. So now we take out a red pen and draw a vertical line at x equals 3/4. Okay, so now we've got an asymptote at x equals 3/4. We're also going to draw our asymptote at y equals 0. So dotted lines to show that the graph will not go through those points. Step 3, plot points on our original and our reciprocal graphs. So we had a couple of points that we already have on there. Can you see that we had 0, 3? So now on your reciprocal graph, so if you did one graph in pencil, maybe you would do your reciprocal graph in pen, you're going to have the point 0, 1/3. Oh, I forgot the negative with the 3 here. Perfect. What's another point that we have? We have the point 1, 1 on our original graph. We are going to have the point 1, 1 on our reciprocal graph. Because if you did 1/1, that would still be 1. Another point that we have up here that we labeled was 2, 5. And on our reciprocal graph, we would have 2, 1/5. It's already really close to that asymptote. Now, if you just played connect the dot with the blue ones, you wouldn't know what the graph would look like. This is where step 4 comes in. Show the asymptotic behavior. What that means is that your graph will get closer and closer to asymptotes but not go through them. So on this section here, these 2 points are going to get connected, and your graph has to get closer and closer to these asymptotes without touching them. So you draw arrowheads.
Don't even think about touching the asymptote.
And even if you have only one point, so I have only one point here, but because of my asymptotes, I know that it can't go up because then it would go through my asymptote. It must go down so that it shows the asymptotic behavior, and it must go this way, closer and closer to that asymptote. And that's how we get a reciprocal graph. Questions you can do for this one from the homework are 4 and 5.